So, we've seen what can go wrong. Is there some way we can build future reactors so they are safer and less likely for these sorts of problems? And are there other ways we can make reactors better? I'm going to talk about three broad thrusts in modern reactor design, and this is only a very brief introduction to a huge topic. One is breeder reactors, which give you unlimited fuel, then intrinsically safe reactors, which are relatively resistant to these sort of problems we just talked about, and small modular reactors. So what's a breeder reactor? Well, if we were powering the entire world's electricity with nuclear reactors, there's actually not that much uranium in the world. There's enough to power the world for decades, but not centuries. So if you're powering the whole world, as opposed to 4% of the world, with nuclear fission, we would run out of power in a few decades. And there are ways to deal with this. Breeder reactors turn otherwise useless uranium-238. Remember that of typical uranium, only 0.7% is a useful uranium-235, and the rest is the uranium-238. Even enriched uranium is still 95% uranium-238. But in most of these reactors, some of this uranium-238 is hit by neutrons. It doesn't then fission itself, but it can turn it into something more useful, like plutonium. Another thing is to use a different element, thorium, and again put that in a reactor because the neutrons will turn that into uranium-233, which is also something that can be fissioned. So you can get reactors that produce fuel, and it's quite easy actually for them to produce more fuel than they burn themselves. So the idea would be that you'd run a reactor using uranium-235 and in the process convert U-238 to plutonium or thorium into U-233, which you'd then extract at the end, process and use in turn for a new reactor. And so this would give basically an unlimited energy source because there's a lot of uranium-238 and thorium in the world. This also has the benefit the sort of processing can get rid of a lot of the waste. So for example, the waste produced by a normal reactor, a lot of that is plutonium, which has a long half-life, and so if you can then burn the plutonium in another reactor and turn it into something safer, that reduces the amount of nuclear waste. And this sort of reprocessing is actually what they do in France and not most other countries. So why isn't everybody doing this? Well, there are two main reasons. One reason is that the plutonium you get by converting the U-238 into plutonium can be used very easily for atomic weapons. And indeed that is what most atomic weapons use, plutonium. They don't use uranium-235 because it's just too hard to enrich it to the necessary levels. So nuclear weapons are often built by having a reactor to convert U-238 into plutonium. Then plutonium you can chemically extract. You don't need all those fancy centrifuges. And then you can use that to build atomic bombs. So if most of the world were using breeder reactors, producing plutonium, then there's probably more of a risk of some of this plutonium finding their way into the hands of a bad government or terrorists who want to use it for an atomic bomb. That's one drawback. The other is that right now there's just no point. If the world was entirely powered by nuclear reactors, we would be running out in decades, but it's not. It's only 4% of the world's energy. There's actually plenty of uranium. Uranium is cheap. The cost of uranium for fuel is a very small part of the total cost of running a reactor. Most of it's the designing and the safety features. So in fact, there's just no economic incentive to do this. But it's something to think about in the future if nuclear takes off big time and we need huge amounts of it. If we can manage the risk of proliferation. How about building reactors that are safer? Well, one thing is you could look at what happened with Chernobyl, with hundreds or thousands of people dead, as opposed to Fukushima or 3 Mile Island with nobody dead, and see that there are many things in a design, like putting a really thick concrete container around everything. The containment makes things a lot safer, but there's more to make things safer. One possibility is you design the reactor so that if something goes wrong, it automatically shuts down. For example, many reactors, the control rods are held at the top by electromagnets. If the power cuts out, the electromagnets switch off and the control rods fall in and shut down the nuclear reaction. And in fact, most or many reactors already do this. The harder thing is that residual heating, because remember that in both Fukushima and 3 Mile Island, the reactor had shut down. the accident happened afterwards, because you still have radioactive elements still generating 3% of the heat even after the reactor is shut down. And that's harder to deal with. What people are working on is reactors that don't need active cooling for a while. So even if the supply of cooling water shuts off because the power supply goes out, for example, because your diesel generators have been washed away by a tsunami, then the reactor, at least for some length of time, will keep itself cool by, say, natural convection or something like this. And so there are a number of reactors boasting that if the power cuts out and the cooling goes away, they still won't melt down for some length of time. I don't think anybody has one that will stay safe forever, but certainly you can get ones that will stay safe for maybe 72 hours, giving chance for emergency workers to arrive there and plug up some other generator, because if there's got 3 days, hopefully you can do something about it. So this certainly makes things safer. Perfectly safe, I don't think that's possible, but it's certainly safer. Another, at the time of writing, very trendy idea is so-called small modular reactors. Basically, the cost of building and running reactors has got out of control. We'll talk more about that later. Also, the current reactors have to run at near full power all the time, partially because of the design. It's very hard to throttle the power down, and secondly, because they cost so much to build, you have to produce electricity all the time to make your money back. The idea is that maybe you can produce small modular reactors, these reactors that would power a small town rather than a city. But the idea is they can be mass produced in a factory, and that, like all mass production, bring the costs way down. And maybe you can design them so they can turn up or down their power output a bit, so-called load following, and have lots of safety features, so include all the new techniques we've talked about. So there's a lot of companies looking at developing these things, the idea being something produced in a factory, shipped out, placed wherever you need it, rather than a few mega expensive, mega big reactors. The load following, which is where they ramp up and down their power, is still not great, but it does, at the moment, nuclear reactors tend to put out full power all the time, and they expect everything else to adjust. So when there's low demand, like the middle of the night, or at the moment, the middle of the day when solar is really strong, the reactors still keep going, and you hope that the coal plants or the hydro or something else can shut down. But if we get most of our power coming from nuclear, this becomes harder. Where are these at? Well, there's a lot of companies and governments developing them, and the first experimental designs will go into operation in the next few years. Now, these are controversial. Some feel that the small modular reactors have been used by the fossil fuel industry as a delaying action. That's certainly happening in Australia at the moment. People are saying we don't need to build solar or wind. These wonderful new small nuclear reactors will come along in a few years' time. But the crucial thing is that few years' time, the first prototypes are still a little ways away, and between first prototype and massive rollout is going to be probably at least a decade or more, simply because of the time it takes to get permits, to find sites, to go through planning approval, to get the bugs out of the system. So this is basically saying do nothing for 20 years and then we'll get these small modular reactors, and as we've seen, the global warming is urgent. We really can't afford to wait that time. Also, because they're an unproven technology, we don't know how cheap they might be. They might be a lot cheaper than current nuclear, which is prohibitively expensive, but we don't really know that. We don't really know how low the prices will go. So these could be a big thing in 20 years' time, and a particularly good thing for countries without alternatives. But right here and now, at least for Australia, I wouldn't wait for them. There are other things we can do that are cheaper and better sooner.